Okay, so now we're going to learn about systems of linear equations and how to solve them graphically. So a system of linear equations in two variables is a set of two or more linear equations. A solution, so when we solve, we get a solution. The solution to the system of two linear equations in two variables is an ordered pair that satisfies both equations. It's basically the point where the lines cross. That's the solution, okay? And it's an ordered pair x, y. Okay, so example 1. Matt owns a truck and estimates that insurance and gas cost him $250 a month. He's considering purchasing a used motorcycle for $4,000 and estimates that if he drives this instead, then he will spend $150 a month on insurance and gas. Write the following. His total expenditures, so that's what Y is, the total expenditures for the truck after M months can be modeled by, and a lot of times I was just working actually with a sixth grader on word problems. Everybody hates word problems, it seems like. But he noticed that in order to really understand it, he had to read it twice. So let's all read it again. Matt owns a truck and estimates that insurance and gas cost him, okay, now I might underline some things, $250 a month. He's considering purchasing a used motorcycle for $4,000 and estimates that if he drives this instead, then he will spend $150 a month on insurance and gas. So can someone tell us the equation total expenditures Y for the truck after M months can be modeled by? Who thinks they can take a stab at that one? Y equals mx plus b. Okay, let's use the numbers here, right? So he owns a truck. He estimates the insurance and gas is going to cost him. So does he have to buy the truck? He already has it. So that's zero purchase, right? But every month, how much money does he have to spend? Oh, so the y-intercept in that case would be 0, right? Because he doesn't have to spend anything outright. Y equals 250 times what? M, 250 per month. Phew, we got it. Okay, his expenditures Y after M months. So his expenditures is Y. That's what the definition of Y is what are his monthly expenditures, or his total expenditures, I should say, not monthly. After M months, if he purchased the motorcycle. So with the motorcycle, he actually has to buy something now, right? How much is he going to spend when he buys it? $4,000. How much does he have to spend every month? $150. So who can give me the equation? Y equals 4,000 plus 150. And we could use X, but we're using M because they gave us that variable. Now, actually, it's interesting. I heard some people say Y equals 150M plus 4,000. Is that the same thing? Yeah, it is the same thing. With addition, we call and that's something we hearken back to in Math 60. The addition property is commutative, which means that it doesn't matter which order we add in. Anything else not matter the order? What other property or mathematical operation would be commutative? Multiplication is also like that. But usually we put the number in front of the variable, otherwise it looks like an exponent. And we don't want m to the 150th power. That will be way too much money. Okay, these two equations are graphed in figure 1. What is the solution to the system? What does it represent? So they already went ahead and graphed it for you. Now, just looking at the two graphs, can you actually tell which equation belongs to which line? You notice that we have two lines graphed? Is there one? Can you tell which equation is which? Which one is this line right here? I'm going to draw it in blue. This is the motorcycle. Motorcycle. Okay? And that's, how did you know that that was the motorcycle? What about it gave it away? Ah, the y-intercept was 4,000. And this y-intercept, he already owns the truck. He doesn't have to pay anything. So this one right here, the green line, is the truck. Because I guess it costs more to insure the truck. That seems surprising to me, just because like I would think a motorcycle is more dangerous, but whatever. It's just me. Okay, so the truck has more insurance. Oh, guys, maybe the gas is more. That's where they're really getting you. Okay, what's the solution to the system of equations? And what does it represent? The solution, we said, is where two lines cross. Yes? What would it be? Oh, I see that. Okay. So I love how you put it in an ordered pair. This is our x-axis or m-axis, and this is our y-axis on expenditure. She put it in an ordered pair, and then she actually even went ahead and said what each represents. So the solution, and we're really big in math on sentences. We can all write sentences. The solution is 40, 10,000. What does the solution represent? She said in 40 months, the cost is the same, 10,000. So basically, the truck is, more expensive every single month, but at a certain point, it starts out being cheaper because he doesn't have to pay, he doesn't have to buy it, he already owns it. So that is why it's climbing faster. The slope is greater, but the slope on the motorcycle is less, and so eventually they cross. Now, you said there were two kinds. Weren't there some lines that you said never cross? Parallel lines never cross, so they would have, and they have to have the same slope. So that's something to look out for. If he were in this situation and it didn't matter about the gas and the insurance, if they cost the same, then they would never ever cross. But because the truck costs more to operate, even though you're starting out at a higher number for the motorcycle, then that allows the truck to catch back up to the motorcycle, and eventually they cross. So systems of equations have a solution if the lines cross. If they don't cross, do they have a solution? No. So you already know two different kinds of systems. One, they're going to cross, or two, they're not going to cross, right? All right, let's go on to the next page. So recall that linear equations in two variables are graphed as straight lines and are generally written in the following three ways. So these are three of the ways we learned about linear equations in Math 60. So it's a little bit of a review. We have standard form, which is ax plus by equals c. That's like the group work I gave you was written in standard form. Okay, even though it had fractions, these letters A, B, and C were just fractions. Slope-intercept form, a lot of people are familiar with this one, y equals mx plus b. This sounds familiar to you? And then point-slope form, which is interesting. This is a variation. The point-slope form that we learned in Math 60 was y minus y1 equals m times x minus x1. Do you see how those are similar to each other? What's the only difference between this point slope form and this point slope form? What did they do? What's that? The y1. If we add it, you see, you can move it over to the other side. Okay, now this is something I want you to always be doing in with every single problem you solve, is the idea of a check. And we're doing it right away. Determine if each ordered pair is a solution to the system. If I take this ordered pair and I want to know if it works in both, what can I do to figure that out? Plug it in. That's exactly what we're going to do. So we go, here's our x, here's our y. It's very important because the way this is written, it's sort of like backwards. The y gets replaced with a 3, equals 1/2 times 4 plus 4. And we want to know, does that work? So, did I plug it in right? Okay. What do you guys think? 3, we want to know, does this work? So it's a question, isn't it? Is half of 4 is 2. 2 plus 4 is 6. 3, does 3 equal 6? No, 3 doesn't equal 6. So no, 4, 3 is not a solution. Now, this is the sad part for me, is a lot of times students will go ahead and they'll know what the answer is, but they won't actually say it. So you actually need to go a step further and always state your answers. Okay, now I want you to try 2, 5. If you know if it works in one, then check and see if it works in the other. It's only a solution if it works in both. So go ahead and try that right now.